Welcome again. Here I am with a new chapter, which is chapter number 5 in your NCERT book, that is laws of motion. So without delaying much, let us start.
Till now we were dealing with only state of motion. There was no concern which causes the motion. Is there any external factor that has caused the motion, is responsible to change the state of motion? We had no concern for this. So that was dealt in kinematics. Now onwards we have to see what is the cause of motion, which is mainly the force. So force is the cause of motion, and now in this chapter we will learn about force. So let us start now. What is force? Force is something that is required to change the state of motion. Now what is state of motion? This is change in state of motion. See, motion of an object is represented by its velocity. So velocity actually is measure of state of motion. So whenever we are saying that force is there to change the state of motion, so force is responsible to change this velocity of object. So this is how we can describe a force. It is required to change the velocity of object. Now this velocity can be 0. So if it was 0, it will have some non-zero value on application of force, or this is also possible that magnitude is not changing, only direction of velocity is changing, or maybe both are changing. So force is responsible for, we can say, change in state of motion or change in velocity of object. Velocity is measure of state of motion. Now let us first consider what kinds of force are there in universe. So in chapter 1 itself we had a classification of force that I had not included in our session because those facts were not needed for JEE or NEET, but this time before starting the study of force, how it can be measured, I will discuss in a short what are the different types of force in nature. So let us see. Here I have categorized the force. So basically in universe, force can be categorized in 4 ways. First is gravitational force, next is electromagnetic force, third one is strong nuclear force, and the last is weak nuclear force. So we will see in brief what these forces are, what causes these kinds of force. Gravitational force, as you must be knowing, this is the force which is between any two bodies which is having mass. So this is force for which the physical quantity which is responsible is mass. If an object is having mass, it will be experiencing gravitational force or it can exert gravitational force. So this is the force that is acted between any two body which is having mass. So the first factor that is responsible for this force is mass. Mass should be there. The next thing that we know about this force is that it is an inverse square law force. What is inverse square law force? Any force which does follow numerically this rule, F is proportional to 1 by r square, where r is separation between the objects which are experiencing the force. This kind of force is called inverse square law force. So gravitational force, you must be knowing its magnitude also between two particle mass. If we write, that is equal to g m1 m2 upon r square. So F is proportional to 1 upon r square. This is called inverse square law force. The third thing is that it is a long distance force, long range force. If we see theoretically, then this range actually goes up to infinity. So we can consider that up to infinity this kind of force is effective. So it's called a long range force. One more thing is there about gravitational force, that contact is not needed. So this is no contact needed between two bodies which are exerting forces on each other. So these are the different speciality about gravitational force. Now if we consider its strength, so its strength actually directly we cannot write the strength, so it has to be in terms of relative strength. So if we consider strong nuclear force as having the strength 1, then this relative strength can be written as, for gravitational force it will be, relative strength is 10 to the power minus 39. So this is the weakest force among nature. Gravitational force is the weakest force. Generally we do not experience this force among us. Of course we can experience this force when this is exerted by earth, because earth has a huge mass, but between any other two bodies this is generally not experienced because it is very weak force. Now next is electromagnetic force. As we must be knowing that mass is needed for gravitational force, so charge is needed for electromagnetic force. So the responsible factor is charge here. The basic thing that is required is charge. It is not only electrostatic force, as it is written here, this is electromagnetic. So it does include electrostatic and magnetic force both. Now what is electrostatic force? For electrostatic force only charge is needed, but for magnetic force moving charge is needed. So actually though charge is the basic thing that is required for this kind of force, but if it is a magnetic force it must be movement of charge. The next thing is about its mathematical nature. Of course this also is inverse square law of force. Again F is proportional to 1 by r square. You must be familiar of this kind of expression. The third thing is this also is long range force. It is effective almost up to infinity. So this is a long range force up to infinity. Theoretically we can see after some distance of course force becomes very weak. It cannot be experienced. Its strength decreases, but still theoretically we can say that it is effective up to infinity. Here also no contact is needed. So you can see all these conditions are same for both gravitational and for electromagnetic force. The next is relative strength. Here the reference I have taken as strong nuclear force. So if we compare this, then relatively it is 10 to the power minus 2. Its strength is 10 to the power minus 2. Now you can see how strong this is if it is compared with gravitational force. This is 10 to the power 37 times stronger than the gravitational force. So this can be experienced very easily between any two bodies if they are having charge. The third one is strong nuclear force. This is the force which is responsible for formation of nucleus, because when a nucleus is formed, inside the nucleus, as we know, a large number of positive charges are there, which is the charge on proton, and they must be experiencing electrostatic repulsion among them, but still they are binded inside the nucleus. What is the reason for that? This is the reason, strong nuclear force. So it is responsible for binding of nucleus. If this force were not there, there would have not been any nucleus structured as it is. This is responsible for binding of nucleus. Now we cannot say anything about its mathematical formulation. It is not yet derived what kind of force is there mathematically. So we cannot exactly calculate its value, but of course this is a very short range force because it is effective only inside the nucleus. So its range is very short. It is only up to the distance of 10 to the power minus 15 meter. Now this small distance can be only inside the nucleus. So this is effective only inside the nucleus. As I had said earlier also, I am taking relative strength as reference as 1 for strong nuclear force, that is the reference, and then we are comparing all other forces with respect to strong nuclear force. The next one is weak nuclear force. As the name suggests, it is of course weaker than the strong nuclear force, and this is actually responsible for radioactive decay. So this is again very short range force, and it is responsible for radioactive decay, because as we know in radioactive decay, beta particle is emitted. So if beta particle has to be emitted and we know that there is no electron inside the nucleus, then from where does this electron come for beta decay? Of course there must be some force responsible for interaction of all the particles inside the nucleus, and that also mainly these are very small particles, not even neutron and proton. These are neutrino antineutrino, these very small particles are there between these very small particles where this force is effective, and that interaction is needed for radioactive decay. I am not going into much detail about how this kind of decay takes place, but it is the force which is responsible for this kind of decay. The next thing is that we know about weak nuclear force is that its range is even shorter than the strong nuclear force, and it is only up to the range of -16 meter. So this is among very small particles inside the nucleus, that is positron, neutrino, meson, this kind of particles, and its relative strength as we compare, then that is 10 to the power -13 if compared with respect to strong nuclear force. So now we got a brief idea about what kinds of forces exist in nature, but in this topic, because it is mechanics here, so in this topic we are concerned only with gravitational force and of course some types of electromagnetic force. This strong nuclear force and weak nuclear force we will see later in class 12 syllabus. Even electromagnetic force also we will see in class 12 only, but some mechanical forces are there which comes under category of electromagnetic force that we have to deal with. So now we are concerned with gravitational force and some contact forces which comes under the category of electromagnetic force in our current topic. Now I am coming to first law of motion, because the name of chapter is laws of motion and these are the laws given by Newton. It comes under Newtonian mechanics. This cannot deal with very small particles or very fast moving particles. That comes under new physics, which is not the Newtonian physics. So we have to consider here only classical mechanics, that is the Newtonian mechanics. The first law he had given was law of inertia. Now what is this law? This law says that there will be no change in state of motion until and unless an external force is applied on a body. And this is the definition of force. What is force? It is something that is needed to change the state of motion. In this actually we are measuring inertia, because we can say more force will be needed if inertia is more to change the state of motion. So from this force inertia can be measured, and it is measured in terms of mass. So measurement of mass has come from this first law only. This law has only theoretical importance. It won't be needed in any numerical solving, but we must be knowing what is force. It is something that is required to change the state of motion, and inertia is something that resists change in its state, and of course measurement of inertia is mass. Come to the next law, second law. This is very important mathematically, because most of the questions we have to solve with this second law. What is the second law? Second law mathematically defines the force. First law defines the force qualitatively. It only says what the force does, why is it needed. But second law tells what is its quantity. So these first and two laws define force both in terms of quantity and quality. In second law, Newton had said that force is proportional to rate of change of momentum, and later it was discovered that this proportionality constant is equal to 1. So now we can directly write F is equal to dp by dt. This is rate of change of momentum. Now as you know, momentum is mv we can write. So just substitute this mv here, and on differentiating now it can be written as dm by dt v plus dv by dt m. Now it has two terms. In first term mass is changing with time, and in second velocity is changing with time. So the total force, net force, has to be vector sum of these two terms. Generally what do we write? F is equal to ma. Why is it? Because generally mass of a body does not changes with time. There are only few cases in which mass changes with time. Those are called variable mass system. So if mass is not variable, if mass is constant, then of course we can write F is equal to m dv by dt. and dv by dt is acceleration, so it can be directly written as ma. This is how force is defined, but obviously this is only when mass is constant. Otherwise, for changing mass system like rocket, or you can see any water carrying garbage container you must have seen of the municipality, and continuously garbage leakage from that vehicle. So that kind of system are all variable mass system. So for those system it cannot be applied, F is equal to ma cannot be applied, and then we have to write v dm by dt plus m dv by dt. Generally for all other objects we can write F is equal to ma, which will be widely used. Now come to the third law. It says about that action and reaction always occur in pair. They are equal and opposite, and they act on two different bodies. So mathematically if I write, it can be written as F12 is equal to minus of F21. This is force applied on 1 due to 2 has to be equal and opposite to force applied on 2 due to 1. So these are the action reaction pairs. In universe all forces occur as action reaction pair, but do remember that these two forces, action and reaction forces, are actually acting on two different bodies. It is not that both action and reaction are acting on the same body. It has to be on two different bodies. So that is also very important aspect of third law, that action reaction forces are there, they are equal in magnitude, opposite in direction, and act on two different bodies. There is only a single exception in this third law. A single type of force is there, which is magnetic interaction. This is the exception, only exception which we have experienced till now. And of course it was not there when Newton had given the law. At that time magnetic interaction was not in knowledge of people. So if we consider magnetic interaction of two current carrying wires, then we can see that this law is not applicable. Let us say one example. These two wires are here which are having different length. So for first wire I am writing its length to be L1, for second I am writing length to be L2. If current I1 is flowing here, in current I2 is flowing here, then if we write force on 1 due to 2, magnitude wise it won't be equal to force on 2 due to 1. It will be only for the case when L1 is equal to L2, otherwise this won't be correct. So it is the only exception in third law, otherwise for all other forces in nature this is applicable. So by now we have discussed about all the three laws of motion which we will use in incoming numericals and see how these are applied. Next I am coming to resultant force. Why is it to be studied separately? Because it won't be always possible that only a single force is acting on the body at a time. It is not always possible. A number of forces may be acting on the particle at the same time. Let this force be F1, this other force be F2, one more force is there which is F3. So if we write the resultant of forces, that is written by F net, then F net has to be equal to, because it is a vector, it has to be equal to vector sum of F1 plus F2 plus F3. So always when we are interested in knowing what is acceleration of object, then we have to consider the resultant force. This is how resultant force is written. Simply we have to take vector sum of all the forces. Now one special condition is there when forces are balanced. This is not possible if only a single force is acting on the body, because if a single force is acting, of course it has to accelerate. That will be the unbalanced force. But if balanced force is there on the body, then at least there must be two forces or even more than that. So if a number of forces are acting on the body such that summation of all the forces, now I am writing as summation, now it can include any number of force, so this has to be equal to 0. This is called balanced force. Of course forces are acting on the body. We cannot say that force is not there so acceleration is 0. No, this is not correct. Forces are acting on the body but still acceleration is 0. So what must be the condition? Resultant of all forces has to be equal to 0. The next is unbalanced force. So if resultant of all forces is not equal to 0, of course the body will be having acceleration, and then we have to write resultant Fi is equal to mass into acceleration of body. Understood? Let us solve one example based on the concept just now we have learnt. When force F1, F2, F3 are acting on a particle of mass m such that F2 and F3 are mutually perpendicular, then the particle remains stationary. If the force F1 is now removed, then the acceleration of the particle is. Here in the given question, initially the particle is at equilibrium, so net force on the particle has to be 0. But it is also given that F2 and F3 are mutually perpendicular. So what does it mean? That F1 should be equal and opposite to the resultant of F2 and F3. Now let us see that for equilibrium of particle, if we have to write, we can write F1 being equal to, this is magnitude of F1, it has to be under root F2 square plus F3 square, because angle between F2 and F3 are 90 degree. And in absence of force F1, we can write acceleration to be equal to, it has to be net force upon the mass. But as F1 is absent, so the net force will be equal to under root F2 square plus F3 square, this whole divided by m. And from the above expression, we can write this to be equal to F1 upon m. So the sought acceleration is equal to F1 upon m, which is our option number A. Now I have a very basic illustration regarding calculation of force. So let's see the situation. A block of mass 5 kg is moving with a speed of 8 meter per second. Initial speed is given, that is 8 meter per second. Mass is also provided 5 kg. Force of 10 Newton is applied for 3 seconds. Force is given there, that is 10 Newton. Find the final speed of block if force is applied. First is along the motion. So first I am considering the case when force is along the motion. So when force is along the motion, as we know, acceleration vectorially is written as F upon m. Here is the case of constant mass system. So A directly can be written as F upon m, and its direction will be in direction of force. Now when we write V is equal to U plus AT, this will be reduced to simply V is equal to U plus AT, because it is given here that force is along the motion, and so acceleration also will be along the motion. And from here now we can write the values 8 plus, now what is F upon m? That is 10 upon 5, 2 multiplied with time, which is 3 seconds. So that is equal to 14 meter per second. So after time t is equal to 3 seconds, the velocity will be 14 meter per second on application of this force. The second case I am considering is when force is opposite to direction of motion. So this time A again will be F by m, but while writing the kinematical equation, we have to write V is equal to U minus AT, because this time A is in direction opposite to that of U. And from here, if I substitute the values, that will be 8 minus 2 into 3, which comes out to be 2 meter per second. So as you can see how the direction of force is making impact on answer to the question. Now in third case, force is acting perpendicular to the direction of motion. So this time it is actually two-dimensional motion. We have to consider in vectorial form. V has to be written as U plus AT. We cannot simply replace this vector sign with plus or minus, because it is not in or opposite to direction of motion. It is perpendicular to the direction of motion. So let us now write the values. U this time we have to write as 8 I. I am taking x direction as direction of motion. So u can be written as 8I and a has to be, of course magnitude will remain the same because that is F upon m only. This is equal to 2 meter per second square, but direction is perpendicular, so it has to be j. Now if I substitute this in vector form, this will be reduced to 8I plus 2. Now t is given 3 seconds, so 2 into 3j, that is equal to 8I plus 6j. And then magnitude of velocity comes out to be, this is square root of 8 square plus 6 square, that is equal to 10 meter per second. This is how kinematical terms can be calculated when force is provided in different directions. Now in coming session we will see how different kinds of forces are calculated with the help of second and third law of motion and all physical situations, and how the physical situation given in a numerical can be solved. We will know about tension, normal and a lot kind of things, even friction later. So let us wait for the coming sessions. Goodbye.